everyone, welcome back to our chemistry lesson. In this video, we are going to look at chapter Chemical Bond. In this chapter, we are going to learn the types of chemical bond and the physical properties of ionic compounds and covalent compounds. There are 4 types of chemical bond in chemistry that you need to know, which is ionic bond, covalent bond, hydrogen bond, and metallic bond. Let's take a look at ionic bond first. Ionic bond is a bond that formed by the transfer of electrons between a metal ion and a non-metal ion. For example, the formation of ionic bond in sodium chloride. A sodium atom with an electron arrangement of 2.8.1 need to achieve stable octet electron arrangement of 2.8 by release one valence electron to the chlorine atom to form sodium ion, which is Na+. And for chlorine atom with an electron arrangement, achieve the stable octet electron arrangement of 2.8.8 when it accepts one electron from a sodium atom to form a chloride ion. Now, sodium ion and chloride ion with opposite charge are attracted to each other by strong electrostatic force of attraction, forming the ionic bond. Next, covalent bond is a bond that forms when non-metal atoms share their electrons to achieve stable duplet or octet arrangement. There are 3 types of covalent bonds, which is single bond, double bond, and triple bond, depending on the number of pairs of electrons shared between 2 atoms. Single bond form when an atom shares a pair of electrons between 2 atoms. For example, chlorine molecule. A chlorine atom needs to share one electron to achieve the stable duplet electron arrangement. So, each chlorine atom will contribute one valence electron to be shared between 2 chlorine atoms. And for double bond, it is formed when atoms share 2 pairs electron between 2 atoms. For example, oxygen atom with an electron arrangement of 2.6 needs to share 2 electrons to achieve stable octet electron arrangement of 2.8. So, each oxygen atom will contribute 2 valence electrons to be shared between 2 oxygen atoms. While for triple bond, it is a bond formed when an atom shares 3 pairs of electrons between 2 atoms. For example, a nitrogen atom with an electron arrangement of 2.5 will contribute 3 valence electrons to be shared between 2 nitrogen atoms to achieve the stable octet electron of 2.8. Thus, the sharing of 3 pairs of electrons will result in the formation of triple bond in a nitrogen molecule. Now, let's take a look at hydrogen bond. Hydrogen bond are attraction forces between 2 hydrogen atoms that has bonded with an atom of high electronegativity such as nitrogen, oxygen, and fluorine. For example, water molecule H2O can form hydrogen bonds among water molecules. As you can see in the diagram here, the red line indicates a hydrogen bond as there is an attraction between hydrogen and oxygen as oxygen atom has a high electronegativity. Strong hydrogen bonds are difficult to break and it requires more heat energy to overcome the weak van der Waals force of attraction besides breaking the hydrogen bond itself. Now for the last type of chemical bond, which is metallic bond, exists when the electrostatic attractive forces between the delocalized electrons gather in an electron cloud. As you can see in the diagram here, metal atoms are arranged closely packed and orderly in solid state. Valence electrons of metal atoms can be donated easily and delocalized, although in the solid state. Metal ions that are positively charged are formed when the valence electrons are delocalized. And all delocalized valence electrons can move freely between the metal structure and form a sea of electrons. Electrostatic attraction force between the sea of electrons and the positively charged metal ions will form the metallic bond. Moving on to the physical properties of ionic compound and covalent compound. Ionic compounds have a very high melting and boiling point. This is because the electrostatic force of attraction between oppositely charged ions in ionic compound is very strong. So, a lot of heat energy is required to overcome the strong electrostatic forces between the ions. And for melting and boiling points of covalent compounds are low. This is because the van der Waals force of attraction between the molecules are very weak. Thus, small amount of heat energy is required to overcome the van der Waals forces of attraction. For the solubility, ionic compounds are soluble in water because water can form bonds with the ions, and ionic compounds are insoluble in organic solvent because ions cannot form bonds with organic solvent. For covalent compounds, they are insoluble in water because covalent compounds cannot form bonds with water. But covalent compounds are soluble in organic solvent because similar types of intermolecular forces of attraction are formed between the covalent molecules and the organic solvent molecules. Now for the last part, we are going to look at the property of electrical conductivity. All ionic compounds can conduct electricity in the molten state and in aqueous solution because they have a charged ions that can move freely, and ionic compounds in the solid state do not conduct electricity because the ions are held by a strong electrostatic force of attraction. Therefore, they are not free to move. For covalent compounds, they do not conduct electricity in any state because they consist of molecules, and this means that they do not have a freely moving charged ions. But some covalent compounds such as ammonia and hydrogen chloride can conduct electricity in aqueous solution. This is because they can dissociate into ions when dissolved in water. And I think that is all for our lesson today. We have learned the types of chemical bonds and the physical property of ionic and covalent compounds. And see you guys in the next lesson. Thank you and bye!